Systems theory is a set of theoretical concepts used to describe a wide variety of things in terms of a model called a system. To give it context, let's talk a bit about its origins. Of course, people have been coming up with abstract theories about how the world works for a long time. Some ancient Greeks thought that everything was made of earth, water, fire and air, whilst others came to the conclusion that it was the expression of perfect geometric forms. Over the years, our theoretical systems have grown into large and sophisticated bodies of knowledge such as philosophy, mathematics, and many other areas of theoretical science, although these theoretical frameworks are often limited to relatively specific areas of interest. During the 20th century, systems theory emerged as a new theory that draws upon many core concepts within these pre-existing methods to develop a more abstract framework that is designed to be universally applicable to all domains. In order to achieve such general relevance, systems theory starts with the abstract concept of a system and then applies this to modeling various different phenomena from biological to social and technical systems. The model of a system can be loosely defined as a set of parts, often called elements, that form a whole which is referred to as the system. A system exists within an environment and has a boundary that differentiates the system's exterior from its interior. An example of this might be a country, interior to which are all the people, institutions, and other elements that constitute the nation as an entire system, whilst the exterior to its boundary is the international political environment. A system can be either open or isolated. Isolated systems do not interact with their environment, but most systems are open, meaning that there is an exchange of energy and resources between the system and its environment. The passing of energy or resources from the exterior of the system's boundary to the interior is termed an input, whilst the reverse is termed an output. Systems develop or function through the input of energy or resources from their environment. They process this energy by transforming it to create an output. If this output is of some value to its environment, it can be termed energy. If, on the other hand, it is of negative value, it may be termed entropy, a scientific term for lack of order, disarrangement, or in more familiar terms, we might call it waste. An early use of this type of model was during the development of the steam engine, where scientists and engineers were thinking about the amount of fuel inputted to the engine relative to the power output and heat energy wasted. By using this model, they could create a quantifiable ratio between them that we would now term the efficiency of the system. Of course, this same reasoning can be applied to a wide variety of phenomena, from the processing of energy within a plant cell to the efficiency of a business organization. We can also model systems on various scales, thus elements can form part of systems that themselves form part of larger systems and so on. This is termed nesting or encapsulation and helps us to analyze a system on various levels whilst hiding away the underlying complexity. Systems theory explores many other areas such as emergence, that raises key questions about the relationship between the parts within a system and the whole. That is, how elements can function together or self-organize to create some new and emergent structure as an entirety. Or other areas such as cybernetics, that deals with a system's control mechanisms that allow it to adapt and respond to changes within its environment through positive and negative feedback loops. Systems theory has found application within a wide variety of areas, forming the foundation for many new subjects such as systems psychology, systems engineering, and systems ecology, to name but a few, all of which place an emphasis upon a more holistic and contextualized approach to understanding the world around us.